Welcome, ladies and gentlemen. We're going to examine projectile motion from the point of view of projectiles that are dropped. So those are projectiles that are changing position in the vertical direction only. You should have a piece of paper that looks like this. Make sure you have this sheet in front of you so you can follow along. The question that we need to address is, if a boy releases a ball from the top of a cliff, how tall is the cliff if the ball strikes the ground 3 seconds later? There's only one number that appears in this question, but actually we can glean three numbers from this, and that's part of your task as you work projectile problems, is to determine implied information. 3 seconds is a time period. That's explicit information, but we can find two more pieces of implied information. So let's talk about that. Since the boy releases this ball, we know that he didn't give it any initial velocity. So the starting velocity in the y direction would be 0. So that's one piece of implied information. The other piece of implied information is partly due to what we can choose as our frame of reference. We're going to call the top of the cliff the starting point, so we're going to call that the starting position for y. So we're going to call that yi equals 0. So as you can see, we've got three pieces of information that's numerical to start from. So here's a picture. You need to make sure that you have a picture that looks very much like this on your paper. So go ahead and make these notes on your paper. So you have added to the picture the starting velocity in the y direction as 0 meters per second, and the starting position yi is 0 meters. You've indicated that up is positive, down is negative, and we are looking for the final position of y. Also someplace, make sure on this picture you've indicated that the time period we're dealing with is 3 seconds. Alright, so this might be what yours looks like once you have those pieces of information recorded on your picture. Next, we need to put it into the remaining part of the Guppy's model. We're going to list that given information over here in much the same way we did on the picture. So that's your next task, to go ahead and fill in these numbers. They're the same as the ones you put over here, but we need to make sure that we have everything all organized. These are the values, hopefully, that you have included for each of the pieces of information on this problem. We know that our unknown is the height of the cliff. And our next task now is to find the equation that we need to use. We're looking for the final position in the y direction. So we want to make sure that whatever equation we choose includes that variable. And it appears that this is the only one that does. This will give us a change in the y direction, which could work, but we're not going to bother with that. So this equation is the only one that includes the variable we're after. We could also go through and determine whether or not we could use the other equations. Occasionally you can use more than one equation. Typically, though, on these problems, this will be the equation that you start with for vertical information, this longer one. It's not going to stay very long, though, because as you'll notice, this yi is 0. The vyi is also 0. So these two add-ins in the equation are going to be 0. So essentially all we have is yf equals 1/2 gt squared. So on the next slide, you see how we've dropped that information in. yi was 0, vyi was 0, so these two go to 0. So I just take 1/2 times 10 meters per second squared times 3 seconds squared. 3 seconds squared is 9. Negative 10 times 2 is negative 5. So I have negative 5 times 9, and that gives me negative 45 meters. And since I said I started here, then I went down 45 meters, and that's why I have a negative 45 meters. And we're going to indicate in this sentence, to answer the question, that the cliff is 45 meters tall. Done. That wasn't so hard. Let's try another one. You can stop these videos sometimes if you need to and back them up if I went too fast in places.